In this lesson, I'm going to pull up the lab design so that you kind of get the shopping mall. Where are we at in this lesson? We'll be targeting 4 areas. I've denoted 3 with arrows, and I drew a red box around the bottom area for the resource cluster. So we'll start at the top. With the vCloud Director cell, we're going to be doing some configuration and installing some tools on the server that we had built in a previous lesson. We'll also be deploying the vCNS manager, which was formerly known as the vShield manager, and we'll be connecting the vCNS and also doing some configuration of vCloud to our vCenter cloud. So that's the vCenter server that's actually managing the cloud environment. And then in the vSphere resource cluster on the bottom that I drew the red box around, we'll be building the provider data center information. So that's the provider virtual data center relationship to the physical hardware. So we're kind of laying down that first platform of virtual infrastructure. So let's dig right in. To begin with, I'm going to cover some pre-configuration tasks that we'll need to do in order to get the vCloud Director environment up and running and usable for building out the private cloud. The first item on the task list is installing VMware tools on the vCloud Director cell. And this is not really a requirement so much as it is a good practice. Really, any virtual machine should have VMware tools installed upon it. This isn't a virtual appliance. This is the actual vCloud Director server that we installed on Red Hat Linux. And because of that, it's not using any kind of third-party VMware tools. We'll need to provide that ourselves. So we'll get that knocked out. We'll also deploy the vCNS manager, which will show up as the vShield manager, but it's the vCloud Network and Security Manager. This is going to be required as a tie-in when we go to complete the vCloud Director initial setup. And then we're going to make a relationship between vCenter and vCNS so that the vCloud Network and Security Manager understands that it is being used by and used for the Cloud vCenter. So let's get started by installing VMware tools on the vCloud Director cell. I'm going to go over the steps to do that, and then we'll perform it in the lab. So the first step that we'll want to do, it's pretty obvious, right? We're going to install VMware tools, and we got to kick off the actual tools install wizard. If you've done this in a Windows environment, it's similar, and in the initial kickoff for a Linux environment, you just go in and tell it, hey, I want to start installing tools, and it's going to say thumbs up, let's do it. The next thing, this is where it starts to get, I'm a Windows guy, so this is where it gets a little confusing if you're not a Linux person, is we're going to run some line commands and we're going to have to make a directory for the CD-ROM and then mount the CD-ROM to that directory. It's not just going to pop up, like in Windows and say, hey, I've got a CD-ROM in here. Do you want to install some software? Or automatically do it. We're going to have to do a little bit of work to get that CD inserted. Then we're going to basically unpack or unzip the file that's contained on the CD-ROM. And kudos to the people that can remember the tar xzf vf command, because I always have to look that up. So that's a personal mark of ignorance there, that I can never seem to remember those 4 letters. So I don't expect you to, but we're basically telling it to unpack that VMware Tools version build tar gz file. It basically has a bunch of stuff inside of it that we're going to need. Within that tar.gz file is a VMware install script. And the cool thing is, if we run that command with a -d at the end, it basically tells the script, use all the default answers. Because I tell you, if you run this thing without the -d, look out, you're going to have to answer like 50 questions. And most of them are, I guess you really don't care. Like I noticed that I typically don't care what the answers are. I just go default, default, default. So if you hit -d at the end of the command, it'll just answer all the questions for you. And then we'll want to do a little housekeeping and unmount the CD-ROM so it's not just stuck in the virtual machine. And I put a red flag because I encounter people a lot of the time saying, the unmount command doesn't work. And I say, oh, there's no N in unmount, it's umount. And then they kind of look at me like, oh, that's mean. Because it is kind of mean, the unmount is just umount. But I guess someone wanted to save 1 letter of the command. So it's umount to get rid of the CD-ROM. So let's switch into the lab, and I'll open up the console of the vCloud Director server, and we'll do these steps. Okay, so I have the vCloud Director server up. This is the vSphere client into the home lab. And this was the server that was built in a previous lesson. So all I've done is taken the previous lesson where we installed vCloud Director, stopped, and now we're going to do just 1 additional step with the VMware tools. And you'll notice here it's got that red exclamation saying, no tools are running, and that's really not something you want to see. So let's take care of that. I'm going to open the console of the virtual machine. And we'll get that nice and centered for you. I'm not logged in, so let me log in as root with my incredibly secure password. Okay, so we'll start off the install first. Now I've just hit Control Alt to get my mouse back. Go to VM, Guest, Install Tools. And it's going to basically say, hey, this will make your VM awesome. And you make sure your virtual machine is running. So our VM is running, and we want to make it awesome. So I'm going to click OK. And you'll see down there, it says it's initiated the VMware tools. Drag that over. Install or mount. So that's fine. Let me open the console back up. And you're wondering, okay, if like I said, I'm more of a Windows guy, and there's no pop-up, there's no anything. So we have to run these commands in order to get the actual tools installed. So the first one is we're going to make a directory called mount/cd-rom. MNT, we pronounce that as mount. And there we go. If it's already made for some reason, maybe your template already comes with it, or someone else built the server, you try to run it, you'll just get an error saying that it's already existing. So that just means someone's already made that directory. Then we're going to change to the mount directory, cd-rom, so cd is changed. And if I hit pwd, present working directory, it'll tell me that I'm in /mount/cd-rom, so we know we're in the right directory. Next, I'm going to actually mount the cd-rom to this folder. So let me run mount/dev/cd-rom /mount cd-rom, just saying I want to mount the cd-rom device to the mount cd-rom folder. And there we go. It's telling me it's doing it read-only because this is an ISO file. It's a CD-ROM. And, we all know you can't write to a, write-protected CD-ROM, so it's just giving you the warning. Now, if I do a directory lookup of where I'm at, we'll see... let me go to Mount CD-ROM. There we go. We'll see that we've got the VMware tools 9.0.1-913578.tar.jz. It doesn't really matter what the version is as long as it's the latest, whatever it is you have in your vSphere environment. And that's basically version 9 build 913578. So that's cool. We now see the file. What I'm going to do now is I'm going to move to my prep folder because I don't want to actually put stuff into this folder. So I'm going to go to the prep folder that was made in an earlier lesson, CD prep. And if you'll recall, this is where I kind of had my stuff for VMware vCloud. Got my certificates file, my libx DMCP file for vCloud Director, and the actual installation. So this is where I'm kind of keeping my stuff. This is where I want to put the extracted VMware tools files. So now I'm going to extract the files by hitting or typing tar xzvf, it's -xzvf, and then mount/cd-rom/ I'm just going to type VMware and hit tab, and it'll automatically complete the file name because it starts with VMware, and hit enter. And it's going to see, you're going to see all this stuff flash by the screen. There's all this stuff that it's unzipping out of that file. There's no errors, looks good, so that's okay. If I do another look in here, now we've got a VMware-tools-distrib folder, so cool, looks good. We'll go into that folder, change directory, VMware-tools tab, it'll complete it. And I'm not going to do a look in this directory because there's a ton of stuff in here, but we want to run /VMware-install .pl and then -d for the defaults. This is basically saying I want to run this script. / is I want to run this script with the defaults. So run that. And these are all the questions that are kind of flashing by your screen that you would have had to answer. And it just answered all the questions for you. You didn't have to do any of that stuff. Very handy. There we go. More questions. It's answering. It just keeps answering all these questions. Okay, the VMware tools are installed, and there's a fun little message from the VMware team saying, it's done, have a nice day. And they're actually kind enough to go ahead and eject the CD-ROM, which is nice. So let's go ahead and unmount the CD-ROM, just make sure it's unmounted. We'll type umount /mount CD-ROM. And it's not mounted, so we verified that it was ejected, which is good, what we want. And now I'm going to reboot the server. Type reboot, and it's going to reboot immediately. So make sure this isn't in production when you do that. All right, let's get back to the pre-install configuration checklist. So the next thing we want to do is install the VCNS manager, formerly the vShield manager. So I'm going to switch back to the lab, and we'll deploy the vApp. Okay, so I'm back in the lab, and here's the vCloud Director folder. Again, all we have is that Cloud vCenter and the vCloud Director virtual machine. So we need to add a third virtual machine, or a vApp in more correct terms, to our little management cluster. So in an earlier lesson, I went ahead and downloaded the OVA file for the VCNS. If you don't have it, go back to your evaluation of vCloud Director on the VMware website, and just go and log in with your evaluation email and download the OVA, or just go back to the previous lesson that shows you exactly how to do that. So let's grab it and deploy it to the environment. Just go to File, Deploy OVF Template, and let's browse. I put it on the desktop, so it's right here. Again, VCNS is not shown anywhere here. It just says vShield Manager, so you just got to remember that. Next, and we'll answer a few questions. So we'll see that it's vShield Manager, version 5.1.2. That's fine. It's now verified that the publisher is really VMware, so that check mark is good. And here you get kind of the same when we went over the vCloud Director appliance, and I talked about thin and thick provisioning. It's similar here. If you use thin provisioning, which is where we only write the actual used blocks to disk, it's about 1.8 gig. But if you thick provision, which means you're reserving all the possible space this virtual machine might ever use, it's 60 gig. I'm going to use thin provision because I'm on NFS and because it's a lab. And even for a production environment, there's really nothing wrong with using thin provisioning. It's really more up to, you have to talk to your storage guy and see if you're thin provisioning on the array or not. If you're thin provision on the array, you would thick provision on the virtual machine. So those are kind of questions you'll want to go over. But again, thin is usually fine. I'm clicking next and then read the agreement and speed read it, kind of like the Micro Machines guy with his talking, and make sure that you accept all these licenses, all these license requirements. So I'm going to go ahead and accept and hit next. And then again, vShield Manager, I'm fine with that. I don't have any other in my environment, but make sure the name is something meaningful to you and your team. And I'm going to throw it, because I have vCloud Director selected when I ran the wizard, it's automatically going to put it in the vCloud Director folder. So next, I'm going to put it in my lab cluster, which is, in this case, it's my management cluster, and hit next. I'm not going to use a resource pool. We don't need one. Just the root lab is fine. And then I'm going to put it on my virtual machines data store. That's where I put all my VMs. Click next. There we go. Again, this may be highlighted or grayed out for you. Because I'm on NFS, thin provision is the only option, because NFS does not support thick provisioning without a vendor plugin. But if you need thick provision, lazy zeroed or eager zeroed, and basically the difference is lazy zero doesn't actually write the zeros, but it does allocate all that space. So either way, 60 gigs would be allocated. The difference is the lazy zeroed is just provisioning it, but not actually writing the zeros. Eager zeroed is going to provision 60 gigs and then write all the zeros in for the other 58 gig that aren't being used. So again, we'll use thin provision and make sure you got enough space up here. So I'm good. And then a network mapping, I'm going to throw it on my virtual machines port group. You'd want to put it on whatever port group is necessary to talk back to your vCloud vCenter. So we'll click next there. Just a little, screen showing you exactly what you've chosen in the previous screen. So that looks fine. Again, I don't ever like to power on after deployment. It's just a habit I've gotten into. I always like to make sure that it looks, I like to give it a once over. I'm going to click finish here and let it deploy. I like to give it a once over and just see exactly how it deployed before I power it on. So just, I guess, a cautiousness in myself. So I'll be back when this gets done deploying. Okay, the deployment completed successfully. The vShield Manager is now in the environment. I'm going to close the little box here and click on it. And again, I just like to eyeball it, make sure it doesn't have any weird requirements. See, this is what I'm talking about. 8 gigs of memory in the lab, that's very overkill for me. I don't need 8 gigabytes of memory dedicated to a virtual machine or a vShield Manager virtual machine that's going to manage maybe 8 VMs total. It's just a waste of my lab resources. So I'm going to actually edit this and drop down exactly what it's using for the lab. Now, in a production environment, 8 gig probably isn't a big deal, but when you're running hosts that only have 16 gig, this is half a host for my lab environment. So I'm going to knock that down to about 2 gig just to save me some space here. The 2 CPUs I'm fine with. So that all looks good. Click OK. And now I'm going to power it on. And your lab will be different. If you've got a lab where the servers have 48 gigs of memory or hundreds of gigs of memory, 8 gig, who cares? But for me, it's a lot. So I'm going to power that on. And we'll let it kind of go through its thing. I'm going to click the console here on the vShield Manager. And it's going to run through kind of some initial setup and power on. And that's perfectly fine. You see it's running some scripts. So just let it do its thing. Okay, now that the vShield manager or vCNS manager is fired up. Let's log in. I'm just going to enter to clear off some of the stuff on the screen here. The default login is admin, and the password is the word default in lowercase. So you log in. There we go. And you see the warning, system startup is not yet complete. Please log off and log back on in a few minutes. It's just letting you know that it hasn't quite finished what it's trying to do. So if you could log off, it'd appreciate it. So we're going to exit out and give it a little more time. But I just wanted to show you what that warning would look like. So I'll be back after this is kind of warmed up. All right, I'm back, and I checked really quick to make sure that it's ready to go. That's why there's an extra login in there. So it is. So admin, default, it's all lowercase. Default is like this, by the way, DEFAULT, all lowercase. So there we go, and it kind of looks like a switch if you'll notice. There's it just has a manager and a little kind of greater than sign, and it's not very helpful. Like, what do I do? So let's go over exactly what you do to set this thing up so that we can complete the deployment of this device. So the first thing I want to do is type the word enable, and this is going to enable kind of more authoritative access to the vShield manager. And it's going to ask for a password. It's the same thing, type default lowercase, and there we go. Now it's a manager with a pound sign, and this means that you're in a privileged mode. So we can run the setup command, just type setup, and it's going to ask you just a few questions, and then you'll be good to go on this thing. So let me put in the IP. My IP that I'm going to use is 10.0.0.86. The mask is a class C, it's 3255.0. The gateway is 10.0.0.200. The DNS is 10.0.0.4, and again, these will change depending on what you have. I don't have a secondary DNS. And search list is glacier.local. It'll be your domain name, basically. Do I want to save the configuration? Yes. And then it says, very, very politely, please log out and log back in. It's always nice. So we'll exit. Log back in, admin, default. Nope, got to wait a little bit longer. So you're going to hit a few of those. So that's fine. I'll exit out. We'll come back when that's ready to go. Okay, I've been logging in and off a few times to make sure it's ready, and it looks like it is. So we'll log in again. Admin, default. There's no warning or anything like that. Looks good. Now what we're going to do now is just a quick ping test to make sure that everything's good to go. So ping, and I'm going to ping the gateway. It's 10.0.0.200. And we're getting pings back, so we know it's good to go. So at this point, I'm done with the command line interface. I can get out of. I just hit Control-C to cancel the ping. So we can get out of this and move into the GUI. All right, so I brought up Internet Explorer, and let's connect to the vShield Manager. So type in the HTTPS for secure and the URL, and I've cheated. I've already been there before. That's why it's auto-filling here. Accept the warning, because you're always going to get one, because the certs aren't signed unless you install the cert on your computer, which I typically don't do. We'll log in as admin. Password is default. Check the little login button there. Okay, so here's the initial config, and I hope you like this page because it's pretty much all you're going to see of the vShield Manager, because we're really not doing anything else inside of this thing other than configuring this kind of screen here. And that's because all the rest of vShield's work will be done and initiated through vCloud Director. So vShield kind of becomes just kind of an extension of vCloud. It's kind of a worker VM or service VM. So let's begin by configuring the lookup service, which is something new to vCenter 5.1. And click Edit. The Edit buttons, they're a little bit hidden here, but Edit Lookup Service, we'll type in the information. So first I'll check the box turning it on because it is optional depending on your version. So we'll go ahead and put in the service host. That's, in my case, that's the vCenter server for cloud, for my cloud environment. You could potentially have it on different servers. So vcenter-cloud.glacier.local. Keep the port the way it is. I'll put in my SSO administrator username. So that's admin at system-domain. Password is super secret, so you can't see it. And there we go. And it'll let you know that the certificate is not, trusted. So you have to click yes to accept it, and you'll see that all over the place. So just keep hitting yes, especially in a lab environment. Who cares? You might be using more legitimate certificates in a production environment, like signed by VeriSign or something like that, or even your own internal certificate authority could be signing it. Okay, so because that went through without an error, we know it's good to go. Otherwise, it would pop up and yell at you and kind of hit you over the head with a frying pan saying to fix it. The next step is connecting now to the vCenter server. So the lookup service and vCenter server are in 5.1. They're two different objects, two different entities. So I'll click Edit on vCenter server, and it's the same deal. Typing in vcenter-cloud.glacier.local. And I'm going to use my administrator, which is an account called root. You would probably want to create a service account, maybe call it vShield or vCNS. And that way it's an account that only the vShield account would be using, or the vShield manager would be using. So mine's root, and my cool password there. I don't know if I typed it right. I'll try it again. And by default, we're going to assign that account to be a vShield Enterprise Administrator. So there's actually different user levels within vShield, and Enterprise Admin is basically the highest level of authority you can give something within the vShield manager. So we'll leave that checked to do that, and we're not doing any of these script plugin things like that. That's you can ignore that. Click OK, and again, it's pretty much if the screen goes away and it looks good, it was successful. We'll accept the certificate there. I wasn't kidding. You're going to have to click yes on those certificates 1,000 times, so get used to it. And then once the please wait thingy goes away, we're all squared away. There's only one other thing to really configure, and that's the time server. There you go, and it kind of refreshes the screen, and you might think, oh, what happened? It's just letting you know that it actually pulled inventory and is successful. So that's what you want to see, last successful inventory, and then the date that's being pulled. So that looks good. DNS was already configured when we did the command line, so you don't have to touch anything there unless you needed to change it. And then NTP, we'll go ahead and give it a time server. And in my case, the DNS and time server are the same thing. Okay, and it tells you need to reboot after changing that. So we'll reboot. I'll reboot out of sync with the lesson here. You don't need to watch me reboot it, but just when you get done, make sure to reboot the vShield manager. And then if you have a syslog server, you can enter the information here. I don't have one. It's not necessary for the install, but that's basically where you'd put that in. And I'll show you real quick. We'll go to users, and you'll see here what I was talking about with the enterprise admin. We now have this root account on vCenter as an enterprise administrator. So it's a global admin. It can manage anything that this vShield manager has access to. So that's what I was talking about when you check the box allowing it to be an enterprise administrator. Okay, so let's get back into the lesson and we'll continue along. All right, so the last thing we need to do in this lesson is the initial setup of vCloud Director. And that basically means that we're going to point our web browser to it and kick off a few tasks in order to get this thing ready for future lessons. So I'll say the first thing you need to do is make sure you have your key handy. You'll need your license key that you got as part of the evaluation. So have that just pocketed somewhere nearby. And your choices for browsers for vCloud Director is Firefox or Internet Explorer. Now, I'm a big Google Chrome user, so this has always kind of stuck me in the craw in that I've got to switch over browsers. And for most of the lessons, I'll pretty much always stay on Internet Explorer, so it's not going to be a problem. But if you're on Chrome or an older version of Firefox, you'll have to make the switch just because there are some incompatibilities, and a nag screen will come up every time you log into the web page. Can you just tell the sarcasm there? It's very annoying. Basically telling you need to choose one of these two browsers. So make sure you use a supported browser regardless of what your choice is. So the two actions that we'll be focusing on to tie up this lesson is we're going to attach a vCenter to vCloud so that we've got a relationship between the vCloud Director server and a vCenter server that we're using for our cloud environment. And what this really does is it exposes the resources that vCenter has, such as its hosts and storage, so that we can use those to build the second task, which is create a provider VDC. Without having a vCenter server exposed to vCloud Director and a relationship built between the two, we're unable to do anything within vCloud Director. It just kind of sits there saying, I don't have any resources. I'm kind of worthless. So we'll kick those two off. And then the future lessons will build upon that because we'll have the resources from the lab that we can give out to our tenants or an internal organization, that we can build networks and all that fun stuff. So let's switch back into the lab and kick off the two quick start actions that are necessary to get vCloud Director ready to rock. Okay, so from a just blank web browser, I'm going to type in, let's see here, there we go, got my browser back. The secure HTTPS to the vcd.glacier.local, and again, I have already been there, and that's why it's autofilling from an earlier lesson. So we'll click that. Again, certificate, continue, trust the cert, and there's no nag screen or anything because I'm on Internet Explorer, but this is a unique setup screen that you're only going to see one time. Once you configure this, you can never go back to it. So it's a good time to make sure you really have in mind exactly the answers you want to use. Although I will say a lot of this you can change after the fact, but you won't be able to get back to this screen unless you wipe your cell, vCloud Director cell, and start over again. So let's go ahead and walk through it and get the cell configured for our VMware vCloud lab. So first things first, you have to agree to the license agreement, and I'll spare you the license joke. I'll just scroll through it really quick here and accept the license. Hopefully you've read all of that and committed it to memory. So next on that, now you need your license key. So this is the key. If you don't remember where it's at, it's on your evaluation page on VMware. So that's where you go to vmware.com and you go, you log into the vCloud Director evaluation and pull your key up. It should also be in your email. It was covered in a previous lesson. So we'll grab that and paste it in. Okay, so I've pasted in my key, and it'll be different for you, and the expiration will be different for you. Mine expires April 10th. Yours will probably expire whenever you kicked off the evaluation, 60 days after that. So we'll click Next out of that. And then we need to provide some administrator account details. Basically, this is going to be the highest level authority, kind of root user, so to speak, for vCloud Director. And I want you to pay special attention to the fact that it's called administrator. It's not admin, it's not root. I don't really think there's many products that VMware has that uses the full word administrator. So that can throw people off, where you'll try to log in later with admin and wonder, did I mess the password up or what's the problem? You need to use administrator. In the future, you'll be able to tie something like Active Directory or other accounts to this. You don't have to use administrator, but for the initial piece, you just have to remember that. So I'm going to put in a password. It needs to be 6 characters or longer with special characters and numbers and, alien graffiti and things like that in there. So I'm going to use my typical password that gets past that. Just make sure it's somewhat strong for a production environment and in your password safe, and who cares in a lab. And then I'll put my contact details. So Chris Wall. And I'll use a fake email address, fake@fake.com. Don't try to email that. It's not me. So there we go. So moving on, the next step is system settings. And if you read it here, it says the system name will be used to create a folder for the vCloud Director cluster. So that means all the vCloud Director cells will kind of fall under this naming that you build here. So you don't need to call this VCD1 and the next one VCD2, etc. This is for the cluster itself. So make it a name that represents the cluster of vCloud Directors that you're going to put together for this environment. Now, in this particular lesson and in this series of lessons, we're just setting up one vCloud Director server. So you have one server, one cluster, in one data center. It makes it super easy. You don't really need to think about scale that much in the lab. But in real life, when you're actually doing deployments on these things, these are important considerations to go over, because you may have 2 private clouds in the same data center. They may be managed by different entities. You may have a private cloud for your corporate IT, and then you acquire another company, or maybe there's a test dev IT department that's also going to build a vCloud. So you need to be very considerate of having multiple vCloud environments in here as far as the name and the ID. So what I'm going to call this is just the Chicago Cloud. That's the name of my cluster here. It just represents the fact that I'm in Chicago and I'm building a cloud, nothing fancy. Maybe if you're going to build 2, you might put a 1 at the end. The second cloud would be called 2, something like that. Now, installation ID, again, this is a pretty good job at telling you within the warning. It just means that there's a pool of MAC addresses already predefined for each ID number. So if you put ID 1, it's going to draw from a very specific set of MAC addresses for the virtual machines. Because you don't allocate the virtual machine MAC addresses yourself, it does it. If you had 2 vCloud Director environments in the same data center, and you use the same installation ID, you could have MAC address conflicts, where 2 virtual machines are trying to claim the same MAC address, and that's bad. So basically, the way it works is each vCloud Director cluster needs to use a different installation ID. So if for some reason you had 2 of them in the same layer 2 domain, which is typically your data center, you'd want to have installation ID 1 and then installation ID 2. A trick that I like to use is if I know I'm going to have more, I'll probably go ahead and number this and add a 1 for this one. Let's say we were building out system 2. I'd put 2 at the end of the name, so it's Chicago Cloud 02 with installation ID number 2. And it just makes it easier in my mind to have numbers that match. So anyways, that's how that works. We're just using Chicago Cloud and ID number 1, and you can replace the city name with wherever you live. So next, it's just review telling you what you configured. That's all fine, so I'll click Finish. And there we go. It very nicely says thank you and boots you right out of the little wizard there, a little unceremoniously. So go ahead and log in using your new credentials. and that's administrator, don't forget, and my super secret password that passes the login requirements there. So there we go. Welcome to vCloud Director. You're in, you're done, it's ready to rock. You can actually start building stuff. Well, not really. There's still a little bit more provisioning we have to do. And remember I mentioned earlier about quick start. So this whole area at the top is the quick start, and it's meant to be kind of a helpful way to walk you through provisioning everything you need to do to build your cloud. For this lesson, we're only focused on item number 1, which is attach a vCenter, and item number 2, which is create a provider VDC. All of the other items will be covered in depth in future lessons, but I don't want to just kind of gloss over them with this one. I want to go really deep with them in the upcoming videos. So what we're going to do now is basically the bare minimum requirements to build out the foundation for this vCloud environment so that we can build upon it later. And that just boils down to we need a vCenter because we need resources, and we need a provider VDC because we need to build stuff on top of that. That is the base level of logical resources that everything else uses, the provider VDC. So we'll start with attaching a vCenter server. I'll just click the link, and it's a very simple wizard. Give me the information for vCenter. All right, well, we've typed that in several times already, so that's no big deal. vCenter cloud.glacier.local. Keep the standard 443 port. That's what it uses to communicate. I'm going to use my root account, but again, you probably want a service account. Maybe call it vCloud, just so you're not using the God mode password over and over again. So I'll put in my password, vCenter name, and this is what it's going to show up as in the list. I'll show it to you later, but it doesn't have to be the exact name of the vCenter server. So I could even call this the Chicago vCenter for Cloud server. And that's literally what it's going to show up as in the logical view when I manage resources. So if you don't like how long that is, you could just call it Chicago vCenter, whatever you want. Description could be this server manages vCloud resources in the Chicago data center. I mean, you don't have to write a novel there. It's not War and Peace, but it's something a little descriptive can help because, you may not be the only administrator in your team. It's very common to have several folks in the same team. And then what I like to do is I go ahead and click for the vSphere web client URL, I go ahead and say use the following URL, and I look it up. I've not had great success with the use vSphere services to provide the URL. In fact, it even puts up a warning saying that it cannot provide the URL. So rather than mess around with that, I like to use this method here. And I just cheat. I go to a new browser tab, and I just connect to the vCenter server that's managing my cloud resources. So in this case, it's https vcenter-cloud. Click that there. So that's the server. It's going to give you another certificate warning. Continue through that. And right here it says login to vSphere web client. I can just right-click that, say copy shortcut, and then go back here and paste the shortcut. And there we go. I mean, it doesn't get much easier than that. You don't have to remember any of this. I mean, if you do want to remember this, it has a little kind of hint right there, and you can fill it in. But I like to be absolutely certain, so I just go ahead and snag it from the URL of the server itself. The one thing I would like to do, though, is I don't like having it without the fully qualified domain name. So I'm going to finish that up with glacier.local. I don't want to just use the short kind of NetBIOS name of the server. So click Next. And it didn't give us any warnings. And that's, again, that's the indication that it's working. It won't let you just get to the end because it's going to check these passwords. So I'll just prove that out real quick. I'll add a false character there to my password. And now it's going to warn me that it couldn't connect to the vCenter server. So there we go, failed to connect. So it's kind of built in as you're doing it. That's going to keep checking the information that you're putting in there to make sure it's legit. That's kind of nice. So now we need to tie into the vShield manager. And this specifically is the vShield manager that the vCenter server is using. Every vCenter server should have a one-to-one relationship with one vShield manager. So if you had a large deployment you're doing where it's multiple vCenter servers talking to multiple vShield managers where you have a lot of one-to-one relationships, every time you enter this vCenter information, you need to make sure to use the specific vShield manager that vCenter server is talking to. You don't just pick a random one out of the pool. So I'm going to type in the IP, which is 10.0.0.86 for the one we just deployed earlier, admin and default. And if you wanted to make another account for this thing to use, you're more than welcome to. It's in that users page that I showed you. I'm just going to be lazy here and use the admin account because it really isn't a big deal either way. And I'm going to click Next. And it's going to show me a list of things. Again, it checked to make sure the account is legit before it let me get to this page. So I know the password and account that I used is a legitimate account. So it's just a review showing you what you're going to do. That's fine. I'm going to click Finish. And that one's pretty quick. There's really not much that goes on. And if you'll notice, everything was grayed out down here, and even some of the stuff was grayed out. Now it's all lit up, because once you have vCenter, you can really start building, because before that you didn't have any resources. So the next thing we want to do, or really the final thing we want to do in this lesson, is create the provider VDC. And this is a really important step, because this is going to provide all the resources pretty much for everything else. All of your organizations and tenants and departments will use resources out of an organizational VDC, and an organizational VDC gets everything from a provider VDC. So we're building, to use that house analogy, kind of vSphere is the ground, and the provider VDC is the foundation of the house, and everything's built on top of that. So we'll click through this wizard, and we'll talk about it as we go. I'll click on the Create button. So the first thing is the name, and it's interesting how much thought you can put into a name like this. The more traditional way to do it is the name should reflect like a metal, so let's say gold, silver, bronze. And a lot of times what I'll see is the compute level and storage level and things like that will relate to kind of the rarity of the metal. So we'll say gold may be the best compute, best servers, the best blade servers, maybe the fastest storage, something like that. Or it may be that gold is the most highly resilient. It's got extra switches, it's got extra UPSs, it has an SLA, which is the service level agreement, of 5 nines. Maybe it's backed up real time. It's got, really nice disaster recovery, tape backups, things like that. Either way can kind of define what your metal is going to be for gold, silver, bronze, something like that. Or you can call it tier 1, tier 2, tier 3. But you need to go into it kind of understanding what you're going to classify things as. If you're going to call it gold, there needs to be kind of an understanding of what gold is, an agreement with you and the business and the organization on if something's gold, it gets X. So I'm going to go ahead and call this gold. This will be our gold tier of resources. And by this particular lab, we're calling it gold because it's all we have, and it's going to be the best of what we have. It's going to be all the best servers and storage and things like that. But yeah, it's going to really depend. So for our use case, we're going to call this gold. This is going to be the best tier of compute, storage, and network that we can provide. We don't have any other tiers at this time, so we'll just go with this being the best. And so in the description, we can say it's the best compute layer. It's the highest storage tiers and continuous backups, something like that. It really depends on your use case. But for us, we're going to provide the gold. This will be the gold standard of compute and resources that we'll provide. Then you've got the choice of, first you've got the choice of enabling or disabling it. And that just means when we build it, will we let people use it right away or not? Other admins that are building on top of it. We're the only admin here, so I'm going to leave it enabled. But if you had a big team of admins and you didn't want them touching this, and there's kind of an unspoken rule, if it's disabled, don't touch it, you might want to disable it. The last thing is the hardware version, and it gives you a pretty decent detail down here. It's basically, what are we supporting in this environment? And it really boils down to version 7 is meant for vSphere 4.1, version 8 is meant for vSphere 5.0, and version 9 is for vSphere 5.1. So if I had some 4.1 hosts in here somewhere, I would need to make sure that I set this to 7, because that's the highest level of hardware version I could support globally for this provider VDC. I couldn't take a version 9 virtual machine, for example, and throw it onto a 4.1 host. It just doesn't work. Because everything here is esxi 5.1 or better, I can choose hardware version 9 and be safe with that. So just be aware of what kind of host you're going to have in your cluster and adjust accordingly. So the next is, at first it's kind of weird looking, the picture here. We're basically starting here and kind of moving kind of clockwise. So we select a vCenter server first. So this is the vCenter server that we want to attach this provider VDC to. We don't have any resource pools. I'm not using any resource pools. That, if you think about it, is a way that we could take a pile of compute and kind of slice it into smaller piles of compute. So we could take a 10-host cluster, make a resource pool called maybe gold, another one called silver, give gold a bigger piece of the pie and silver a smaller piece of the pie, and further subdivide. That's not always the best way to go about. If you have the ability to just provide one cluster to the environment and say that is all this tier, like this is the vCloud cluster that I built is all going to be for gold tier, gold provider VDC. To me, that's a little bit cleaner and easier to troubleshoot. And really, there's been some changes that we'll go over on the storage that made a lot of those resource pool tricks not necessary. So what we're doing in this particular lesson is we're just going to give the whole cluster to the gold environment. I've clicked it and now it's all blue. So basically, the gold provider VDC will attach to the Chicago vCenter, which is that vcenter-cloud, and it's going to use the whole vCloud cluster, and that's what we're doing. And there's no networks built yet because we haven't defined any external networks, so that's blank. That's okay. We don't need it right now. So next I want to add storage to the environment. And there's the ability here, I kind of alluded to it before with storage profiles. We'll build some storage profiles in the future, but for right now I'm just going to grab any storage and add it down here. So I just took my ISOs, my SSDs, and my SATA, and they're all available to this provider VDC. In the future, I'll show you how to make profiles so that we can kind of say maybe SSD. You can see I'm kind of alluding to it here. Tier 0 would be SSD, Tier 1 might be SATA, although typically Tier 1 is SAS and Tier 2 is SATA, but we only have 2 tiers. Prior to 5.1, you really couldn't do this. You could only give one type of storage to a provider VDC. So let's say flash. This whole provider VDC would have to be built just for flash. Once I put one flash data store in there, I could only put more flash data stores in there because there was no way to define a storage profile. It was all treated as just one big pile of storage. So with 5.1, we can use storage profiles to further delineate, yeah, I've got a big pile of storage in here, but this is Tier 0. It's a different grade of storage than this Tier 1 SATA is. So again, we'll go over that in a lot more detail in the future. Right now, we'll just grab all the storage and just pile it in there. And then kind of the final step in here is preparing the hosts. And that's where it's going to put the host in maintenance mode and apply some changes to it, install some software and prepare the host to be used for vCloud Director. It actually installs an agent on the host. And we need to give root credentials to the host in order to do that. Now, in my lab, all the hosts have the same password, so I can use this one credential for all hosts option. And by default, it's root is the account. And then let me put the password in here. And hopefully that's the right password. If that's not, if you don't have just one password for all your hosts, you can use this different credentials for each host and type in the passwords for each. Because I've seen some deployments where each host has its own unique password. So it's really up to you how you've got it. In my labs, yeah, just use the same one for everything. So let me click next there, and then we'll finish. And there we go. It's gone ahead and given you the green check mark because it's created the provider VDC. And before we finish here, I'll go ahead and switch over to manage and monitor, and we can kind of see the fruits of our labor here. In that, first off, we have a cloud cell defined. That's the vcd.glacier.local. That's the server we're directly connected to right now. We've got a provider VDC set up called Gold. It's our gold resources. And it has little images here. We got 3 data stores defined. One resource pool, that's the root resource pool of the cluster vCloud. We're tied to the Chicago vCenter, and it's currently enabled, and checkmark means it's all good to go. We also have some vCenters defined here now. Let me expand this out so you can see it. So we got that Chicago vCenter, maps to the vcenter-cloud server. It's running 5.1. And we can also see that vCenter server is tied to this IP for vShield Manager and to this proxy on the vCloud Director side. So you can see all the relationships that were built prior in these screens. And here's the hosts that are available to vCloud Director. We've got the 2 that are in this cluster, hosts 6 and 7, and we'll go over these different check marks because there's a lot. So it's basically saying the status of these hosts is green. There's no issues with the check mark. They are enabled, which means that they are available for use right now. This is commonly disabling is commonly used if you want to prevent people from doing anything with the host from a resource perspective. So if I disable the host, which I'll go ahead and do here, no longer can vCloud place any workloads on that host. So if you need to do some maintenance on the host, you could disable it, which prevents any kind of workloads from occurring on there. Pull it out, replace some hardware, whatever. Ready means that it's been prepared, so it has the vCloud Director agent on it. And then this one, I'll go ahead and expand it out. It says available. It means that it's online and reachable. And then the vCloud Director network isolation is something we'll go over in the future. I'm going to have to play a little sliding game with these columns here. But that means that it's ready for or capable of being involved with vCloud Director network isolation. There's no VMs running on either one of these, and they're part of the Chicago vCenter. So I'll go ahead and re-enable this guy, and we'll move on. So moving down, we've got data stores and data store clusters. Now we're just using data stores in here, and here's the 3 that are presented to the cluster. One I use for ISOs, and the other we're going to use in future lessons for kind of a tier 0 solid state drives and tier 1 SATA drives. And you can see what type they are, how much of it is used on the disk, how much is provisioned on disk, and how much requested storage is coming from the vCloud Director environment. So you can already see that I'm using a good chunk of the storage on non-vCloud stuff. And that's probably going to be the way your lab is too, where you're going to have, you don't really have the luxury of multiple storage arrays at home for the most part. I would assume I don't. So this is just letting me know that, I've consumed a pretty good chunk of that particular storage already on non-vCloud stuff, and that they're tied to one provider virtual data center at this time, and the Chicago vCenter. Storage profiles is something we'll go into much deeper in the future, and just for now, we only have one called any, so there really isn't a storage profile. But if I click on that, you can see what involves any, so basically everything that belongs to that, which of those same 3 data stores. And you might be able to elude the fact that I've got a tier 0 and a tier 1 data store. We're probably going to build some storage profiles in the future, so it's a little bit of a hint right there. But if we had different tiers already laid out in storage profiles, so we could see how much was used versus provisioned and requested, and within each profile, how many data stores actually live inside of it. And then finally, we'll look at the switches and port groups. There's only one right now. I've actually built out a distributed switch that I call vCloud in here. It's currently enabled, and there's no network ports really provisioned. It's kind of a naked switch right now. It's not doing anything. There's only one port group, something that I made prior called external access. Again, networking stuff we'll go into a lot deeper in the future lessons. And that concludes this lesson, so I look forward to seeing you in the next one. Now, this will probably be the most complex lesson within this course, just because networking in vCloud is quite difficult. It's the glue that holds together pretty much the entire vCloud. The cloud is all built upon the networks that tie their virtual machines together. And the real underlying goal of vCloud is that you kind of do a design one time, you make this repeatable design, and then a consumer can come in and provision off that design, and you don't have to go and rework the networking. Now, I'll say anything that you have to design where it'll just be used over and over again without having an admin interact with it, innately becomes just more difficult because you have to design for all those variables. So networking is quite a challenge. Now, I'm going to kind of break it up into different pieces and try to make it as easy to swallow as possible. But don't feel bad if it takes you a little while for this stuff to sink in, because frankly, the networking piece, again, is the most challenging part of vCloud Director. So like I normally do, we'll go over the lab design and what's going to be touched in this lesson by using my creative little red arrows and red box. Now, as you can see in this slide, I've got the vCloud Director cells will be manipulated through this lesson because that's where we're really going to do all of the defining of the rules and the networks and logically creating these networks, as well as the VCNS manager, the vCloud Network and Security Manager, which will also be termed as the vShield Manager, because the vShield Manager is going to kind of play a smaller role in this environment in that it's going to provide the vShield Edge devices or VCNS Edge devices, which we'll use for fencing and routing and doing NATing and a couple different things. But they're kind of on a case-by-case basis. Sometimes we'll use an edge device, sometimes we won't. It really depends on the network that we're building. And then the next thing is the vCenter server that's managing the cloud environment, because that's actually where the network lives. That's where the logical networks have been defined and, where the actual switching is taking place. And then finally, I've drawn the red box around the vSphere resource cluster because that's where the activity is actually going to take place. When we do these different designs on the network and apply them, they actually live in the resource cluster. So that none of the networks that we define are anywhere in the management cluster. It's all defined there and then applied in the resource cluster. So let's move into the various different types of networks that are available in vCloud and go over how they work and what they do and some kind of real-world cases where you may want to use one over another. So to start with, we have external networks. And if you think about cars on a racetrack, they just go round and round in a circle. Think of that as the vCloud environment. Everything's kind of contained within that racetrack. The external network is how you get out of the racetrack. Now, hopefully you're not sitting in the stands and someone decides to just, plow their way through the stands, because that would be painful. But to think of that's how you leave the racetrack. You take this external network and it allows you to leave that environment. Now, I note that that doesn't necessarily mean internet access, because typically I think of external access as that's how I get to the internet. That's external to my environment. That's not what this means as a rule. It could go to the internet, but it could also just get to your corporate LAN, which then gets you to the internet. So by external, all we're really saying is that this is the network that gets you out of the cloud and to wherever it needs to go after that. You pretty much have to define an external network because, again, like I alluded to earlier, if you just have a network that can talk to itself and not to anything else, again, it becomes kind of pointless to a degree, unless that's exactly your use case, which would be odd. I've not seen that where you just want this self-packaged network that only talks to one another. So you're pretty much always going to need an external network. The real decision point is going to be, is that a corporate LAN? Is that a co-located LAN? Is that the internet? It really depends on your use case. A lot of times, though, in the real world, an external network will simply translate to the LAN in the corporate environment. So moving to the next type of vCloud networking, we have network pools. Now, network pools are really how we decide exactly how we define these different types of networks that will be used by the organizations and the vApps and things like that. It pretty much boils down to 4 different types of network pools. And it used to be 3 types back in the old days, but now that we've got some new fancy network tools, we can provide 4 different methods for making pools. So I'll go over them in the order that they're listed. The first is the vSphere port group backed. It's kind of a mouthful. So it kind of has a descriptive name. You can kind of visualize vSphere port group. That's where we're going into the cloud environment, the vCenter server that's running the cloud, and we build port groups ahead of time. So you may go into your vSphere environment and build out port groups for production and maybe databases or development, things like that. And you've built those port groups ahead of time. And then when you build a network pool out, you direct it to those port groups. You tell it, I made this production port group and I want you to use it specifically. Don't do anything else other than use this port group. And here's the IPs that go in that port group. And vCloud Director salutes you and says, yes, sir, right away, I will do that. Or yes, ma'am. This is probably the most rigid and static and kind of non-cloud-like networking because you're having to provision it all up front, and there's no way to really automate that after the fact. You either build it now or maybe you automate the building of it later, but vCloud itself can't build it on its own. You're not letting it. The only real time I see this used in a common scenario would be if you just have some kind of security requirement where port groups have to be provisioned by an admin. Maybe there's a RFC or request for change process that just limits you to this. You may just be kind of stuck with a constraint in that your design is limited to a person pulling the lever and building the port groups. But we really want to try to avoid using that. The other reason you might use it, I suppose, is you need to use a regular virtual switch instead of a distributed switch. Because this is really the only way you can get away with using a standard switch is by using port group backed. The next item on the list is VXLAN backed, and that sounds cool, right? It's got an X in it. Just sounds neat. It's the virtual extensible LAN, and I can almost imagine this guy walking with a cape and some boots and everything and being, I'll save you, I'm the network guy. So VXLAN is kind of the new kid on the block as it relates to the other technologies on the list here, and it's an overlay transport technology. That sounds fancy. Basically just means we're going to take our layer 2 and layer 3 network and we're going to use it to help build a stretched layer 2 network. So let's say you've got disparate layer 3 networks. You've got a 10.0.1 and a 10.0.2 network. Those are 2 different layer 3 networks, but you want them to appear as a 192.168 network. VXLAN can help you do that because the layer 2 frames, Ethernet frames, are kind of hidden underneath the layer 3 network. So you're able to kind of transparently make virtual machines think that they're in the same subnet when they may be different parts of the data center or completely different data centers altogether. And now, there could probably be a whole course on VXLAN. It's a little bit complicated to wrap your mind around. It requires multicasting, which basically means you're using IGMP, querying and snooping, and a lot of fancy terms. We're really not going to touch it that much in this course, but you should be aware that A, it exists, and B, it's really being pushed pretty heavily as we go forward. So when you build out a vCloud Director environment, it's just going to automatically create a VXLAN network pool for you. You don't even have to ask, it's going to do it. So I'm getting the feeling that this is going to be preached a little more than traditionally. But again, it is quite advanced, and realistically, I'm not seeing it that much out in the field just because of the newness of the technology and the fact that the multicasting is kind of a unique requirement that can be difficult to achieve in a lot of corporate data centers. Now, the third one is VLAN backed. And now we're starting to get probably a little more in the comfort zone. VLAN is something you've at least heard of, and a lot of network guys are going to give a thumbs up like, oh, yeah, VLAN. I know VLANs, no problem. And it's a lot easier to sell the idea of a VLAN to your internal team. Like, hey, you guys want to use VXLAN or VLAN? They're going to say, well, I don't know what a VXLAN is, so let's go with VLAN, if you had to compare the two. Now, what VLAN back does is you basically tell vCloud Director, hey, I've got these VLANs, and I want you to use them as you need to. So let's say you said, here's VLAN 500 through 599. Those are yours, and whenever one of my tenants needs a network, go ahead and grab one of those VLANs and use it. And it's automated, which is kind of nice. And in a lot of private environments where you're not using a whole ton of VLANs, it can be very easy to use because you don't really care if it's going to use 100 VLANs or not for your private enterprise. Those VLANs are yours to use or not use anyways, and you get just over 4,000 VLANs before you run out of them. So for a private enterprise, I doubt you're anywhere close to 4,000. You probably have thousands of VLANs left over. So this can be a good way to do a simple deployment of the network. So the final one is the vCloud Network Isolation Backed, or VCDNI. Now this has been a more traditional way to set up an encapsulated network. It is a way to do an overlay network, I should say, where we can use special identifiers in order to help isolate different pieces of the network. It requires just one VLAN. It really doesn't even require it. It'll use VLAN 0, which is kind of none if you don't have one. I typically recommend a VLAN just for security purposes. And it's relatively easy to implement. You don't need multicasting. It does require a little overhead in the Ethernet frame, but really that's about it. So it can be a lot easier to use than VXLAN, has less requirements. It's also quite scalable. Just like VXLAN, although VXLAN you can get thousands and thousands of networks out of it, vCloud network isolation networks are limited to 10 network pools per vCloud instance. So you get less pools, unlike the VXLAN, right, where you get 10,000 pools. But that may be okay. So the only thing I want to kind of conclude with on the network pools is, other than the vSphere port group backed network pool, all the other network pools requires a distributed switch. And realistically, you're going to have, at the very least, enterprise licensing to do vCloud because it requires the use of DRS, Distributed Resource Scheduler. But realistically, you're going to have Enterprise Plus most likely because not having a distributed switch really kills a lot of these networking constructs that you see here. So that's why you're pretty much going to have to choose a distributed switch anyways. I don't really see anyone doing standard switches, but just to be clear, you can use a standard switch for the vSphere port group backed. Everything else requires a distributed switch. As a word of caution, if you're going to use either the VXLAN backed or the VCDNI, which is the vCloud Network Isolation backed network pools, you'll want to enable jumbo frames. This is kind of a weird set of words, jumbo frames, but basically all that means is that we're going to increase the maximum transmission unit, or MTU, to be larger than the standard 1500 bytes that it's normally capped at per frame. So even if you made the MTU 1501, you've technically made a jumbo frame. A lot of people associate the word jumbo frame with a 9000 MTU, which is typically the maximum size that you can make the transmission unit. Some systems will let you go a little larger than that, but 9000 is kind of a standard. This is a jumbo frame. In reality, it's just anything larger than 1500 is really a jumbo frame. So to use these different types of network pools, VMware advises that you go ahead and increase the MTU on all your network gear to 1600 MTU or larger. You could just go ahead and set it to 9000 and be done with it if you wanted. So that means the VMware, the VM kernel ports, the physical switch ports, etc. Everything from source to destination needs to have its MTU adjusted to 1600 or larger. Otherwise, you'll get what's called IP fragmentation. And this just means if it can't fit the entire payload into the MTU size of the frame. So let's say you're trying to send 1600 bytes of data, but your MTU is set to the standard 1500 bytes of data. There's 100 bytes of data that won't fit. So it's going to have to fragment that IP packet into two, one containing 1500 bytes of data, another one containing 100 bytes of data. And as you can imagine, that's inefficient. It basically means you're going to have to send two packets when one would really do the job. And in some cases, if you have a router or switch that specifically will not fragment the packets, you could end up in a situation where the network simply drops the traffic and you're getting all sorts of errors. So with those types of network pools, go ahead and set the MTU on your network equipment to 1600 or larger. And don't forget to set the size of the MTU on your distributed switch as well, as that is technically a piece of networking equipment that's within the stack. All right, so now we're getting into a bit more of the fun plumbing. With the network pools, we're really figuring out how we're going to get the traffic from A to B and how we're going to define the VLANs and things like that. And that, that isn't all the most fun stuff to do, to be honest with you, setting up networks and pools of IPs and such. To me, the plumbing is a lot more fun. And this is where we get into the realm of organization VDC networks. Now, org VDC networks, as we're going to call them, pretty much is limited to three different types. You've got external direct, external routed, and internal isolated. Now, I find that the use of the word external can sometimes cause confusion because we already talked about an external network. So now we have an external org VDC network. That's kind of confusing. So the real kind of reason for that is anything with the word external for an org VDC network means it's talking to the external network. That's it. Org network talks to external network. So we call it an external org network. And I'll show you some examples and we'll go over these three different types. So I've got some graphics here that came out of the VCAT from VMware to help kind of explain visually what we're talking about here in this lesson. So the topmost graphic is a direct connected org VDC network. It's an external direct network. And as you can see, we work from left to right. The virtual machines within the vApp can talk to the org VDC network, which then directly communicates with the external network. There's no router, there's no NATing. It's just a direct connection straight from the org network directly to the external network. And that also means that the IP structure set up in the external network will have to be used by the vApps as well, because we're not doing any NATing, we're not doing any routing, and we're not doing any masquerading or proxy ARPing or anything special. It's just a direct pipe that we're plugging directly into the external network. The next use case is external routed. So the external routed looks a lot like the first network, like the external direct, except we placed a vShield edge device in the middle of the two. And we've also got two different subnets now. We've got the subnet of the org VDC network and the subnet of the external network, and those are different. The routing device will provide things like DHCP, firewall, VPN, and NAT services to the vApp, to that organization VDC network. So it's providing some kind of value add to the org VDC network that you need for your vApp. Because based on your design, you've got the edge device in there for some reason. Maybe you just have it there because you want to have IPs assigned. You're using the DHCP feature to provide IPs to your vApp because you don't want to exhaust the IPs of your external network. Because you can imagine, the external network may only have a small, limited number of IPs available. Let's say that you're consuming this cloud and you only have 10 IPs available. Well, you don't want to consume all those by your VMs and the vApps. You'd only be able to have 10 VMs. That's not enough. So you could throw in some routed org VDC networks to give out DHCP addresses and then NAT it out to the external network. And it's just like your data center now or your computers now where you may only have one WAN address in your lab environment, but you use NAT in order to have multiple computers on your network and your tablets and laptops and all that good stuff. Very similar concept. So the final different design, you see it in the bottom left corner there, is the isolated org VDC network, the internal isolated network. And this one's kind of lonely looking. It doesn't go anywhere. The VMs in the vApp talk to the org network, and that's pretty much it. They can talk to each other using that org network. And if any other vApp was tied to that org network, they could talk to the other vApp, but they're not leaving the org network. You can see there's no external network that they can even get to. So this use case is a bit more used for perhaps you need an application that's only talking amongst itself and you want to see how it performs when some test occurs. I see this a lot for like a pre-production environment where Maybe you want to test a database server that's talking to an application server just to see what happens, and you could throw it on an isolated network to make sure that it doesn't impact anything else in your environment. So the final type of networking in vCloud is vApp networks. Now, vApp networks are interesting because when you build a vApp, that's kind of when you decide how the vApp network should work. And they're kind of on demand. When the vApp is powered on, this network kind of exists and is functioning. And when it's powered off, the vApp network is not needed. It can be, kind of shelved, so to speak. It's powered off. So unlike an org network, which is kind of always sitting there and available and ready to go for any vApp that needs it, the vApp network kind of has an on-off switch to it. And it's the most complex of the list because it has 4 different types of operation, different modes of operation. So a real quick rundown on these 4 different types are direct, fenced, routed, and isolated. And I think after you see how these work, the words and the names will really click. The problem with vApp networks is now we're starting to get really complex because a vApp network talks to an org network, which talks to an external network, and based on how the org network is set up, it kind of changes the behavior of the vApp network, so to say, so that perhaps you have a NAT device in the org network that talks to the external network, and then you have another NAT device between the vApp network and the org network. Now you're doing double NAT. So it's not just that you're creating the vApp network kind of on its own, it also then has to talk to the org network and potentially the external network, depending on how you set it up. So you can have all sorts of use cases. I mean, you can really get fancy with these things. We're going to keep it simple. I'm just going to go over some very basic use cases for these to help start your noodle kind of boiling a little bit on how these work. So again, I have some examples of vApp networks in front of you, kind of like we did with the org networks, and we'll work top to bottom. So the first example is the direct vApp network. And I've included the whole stream. Again, these are from the VCAT that you can look at anytime you want. They're courtesy of VMware. And so the first example is the direct network. Anything direct is always really easy to visualize because there's nothing in between the different networks. The virtual machines within the vApp talk to the vApp network, which is directly connected to the org network. And I'll stop there because at that point, the vApp network being direct is doing what it said it's going to do. It's a direct connection to the org network. The org network then could be any of the other 3 org networks that I talked about previously. It could be a routed or direct or isolated org network. But from the vApp network's perspective, it just needs to directly connect to the org network. That's all it needs to do. In the example I show you, the org network is also directly connected to the external network. So there's only one subnet for the whole thing. Everyone's using that 10.1.1.x subnet. Very easy to visualize, but not necessarily very common because at this point you're building all these networks and it may be used for something, but I don't typically see it where you've got just everything plumbing all the way to the external access in such a fashion. So think of this more as a learning guide and not so much as reality. The second design in the middle is the fenced vApp network. And this is where it starts to get very useful and very interesting. The fenced network basically means that it's a method in order to protect the identity of the virtual machines. And what do I mean by that? So let's say one of your developers comes up to you and says, hey, Mr. Admin or Mrs. Admin, I need to build out 3 copies of the same vApp because I'm testing 3 different bug fixes. And I don't want to test the bug fixes all at the same time because then I won't know which fix cured which bug. So I need 3 identical vApps with the same IPs, the same names, all that kind of stuff. Can you do that for me? And typically you'd say, no, I can't make 3 identical applications with the same IP and the same name. You can't do that on a network because then how would the packet know which VM to go to? I can't, no, you can't do it. That's where fencing comes in. So the main goal of fencing is to allow you to do something like that. You could have 3 or any number of vApps all hidden behind a fenced network. The edge device then performs isolation duties. So it's really just doing what's called a proxy ARP, or address resolution protocol, in that let's say the IP of every VM in the vApp is 192.168.1.1, or we'll even use the IP that they show here, the 10.1.1.x. So if they all had 10.1.1.1, then the edge device may assign them a 2, a 3, and a 4. They all think that they're 10.1.1, but in reality, the edge device is making sure that if you want to talk to the first vApp, you use a 2, and the second vApp, you use a 3, and the third vApp, you use a 4. So it's kind of hiding the actual IPs behind some pseudo IPs, we'll say, some different IPs. And that way, you could go back to the developer guy that asked for the virtual machines and say, yeah, the first VApp is under that 10.1.1.2, the second one is under 10.1.1.3, and the third one is 10.1.1.4. He knows the IPs that you've given him, but the apps don't. So it's a way you can kind of hide behind this special proxy ARP process. If you've ever used VMware's Lab Manager product, this was a big strength of that product because it did this fencing. The next design at the bottom is a routed network. It's very similar in look to the fence network, except it's doing different things. The virtual router there in the edge device sits between the VApp network and the org VDC network. Its basic purpose in life is to provide some services for the networks in there. It provides a new subnet, it provides some routing, provides NAT, firewall, things like that, so that the VApp is kind of in its own different world, its own subnet behind the edge device. And then past that point again, the org network could be direct to the external, as I show you in the bottom example. It could be isolated. It could be routed. It could be anything at that point. We're just focused on that relationship between the VApp network and the org network. And in this case, it's a routed network with an edge router in the middle. The final example on the top is an isolated VApp network. And that one's super easy. The VMs can pretty much talk to themselves within the VApp. That's it. Doesn't go any further than that. In this example, these 4 VMs can talk to one another through that isolated VApp network and no further. Now, the first question that enters my head when I see that is, what is the point of that? Why would you ever want a network that doesn't go anywhere? And that's a good question, but it's a little more common than you might think. So let's go back to an example where we have a 3-tier application. Web server talks to app server, and app server talks to database server. It's a very common configuration for the 3-tier app model. Now, what you don't ever want to happen is having the web server talk to the database server. Web talks to app, app talks to database. That's the pattern. So what you might do is put the app server on an isolated network directly to the database server so that they can only talk to each other on that isolated network. And then you might build another one where the web server talks to the app server on a different isolated network. And that way you've ensured that the web server can only talk to the app server, and the app server can only talk to the database server by using a pair of isolated networks. I'm not saying that's the only way or the best way to do it, but it's definitely something that I see used. So just to kind of throw a little bit of complexity at you, just to show you how crazy this can get, I copied the image of kind of a very complex looking network at the bottom, in which we have a routed VApp network talking to a routed org VDC network, talking to an external network. So there's actually 3 subnets below there and 2 NAT domains. So the 192.168.1.x network is then natted to the 192.168.0 network in the org VDC, which is then further natted to the 10.1.1.x network for the external network. It can get crazy, and this is what I'm talking about, where it gets really complicated. Because trying to put all this in your head and learn it when it's at that complexity, it's just too hard. You shouldn't start with something that complex. You really want to start with those 4 basic direct connected examples that I talk about and branch out from there, especially when we start throwing these 3 networks at each other. And this is just one VApp. Imagine that you had 30 VApps all talking to different VApp networks and different org networks. Like I said, you kind of need a giant whiteboard and markers and stuff to draw all this out because it just gets really, really complicated very quickly, unless you're just in the ground floor on the design helping them do it. So rather than using just the VMware examples, I went ahead and kind of threw together kind of an example of an enterprise vCloud networking model in which we have 4 virtual machines within 2 VApps. So the VApp on the upper left in the blue has 2 virtual machines, and the other VApp, also in blue, has 2 virtual machines. So the first VApp with the 2 virtual machines in the upper left has a red vShield Edge device that is talking to an internal org VDC network. So that's an isolated internal network that doesn't go anywhere. The second VApp on the upper right has a direct connection to a external org VDC network, which then goes to the external corporate network, which also goes to the physical network. In between that upper right VApp, it also has an internal isolated VApp network. So you got all sorts of cool stuff going on here, and we're starting to see, I hope I'm showing you scratching the surface of how interesting and complex and kind of messy it can get if you start going hog wild with all these different network designs. And you may have use cases for all this, but it doesn't make it any easier. You'll really have to document this well and plan it out very well and build it all, with a lot of thought put into it. This isn't something where you just next finish, throw in some IPs and call it a day. You really got to spend a lot of time figuring out how you want to build this so that the consumers of your cloud can just click a button saying, yeah, I want another one of those. Give me an app server, poof, and it comes right out. And the networking just materializes. Like I said, it takes a lot of ingenuity to build a network where just a consumer can click a button and it scales. Okay, so now that we're done with all that fun lecture that I'm sure you just absolutely loved, let's go into the real-world environment of my non-real-world lab. And I'll show you some examples using these different networking types that you just learned about. Okay, welcome to the lab version of the vCloud Director. And I've logged in and I'm at the Manage and Monitor tab, which is right here. So there's pretty much nothing configured at this point. The external networks are empty and there's only one network pool, and that's that default VXLAN network pool that gets built when you first deploy a provider VDC. So we didn't build that. When you're building out your lab, you'll notice that it's the name of the provider VDC -VXLAN-NP. That's just the standard build for that name. We're not going to touch that, but I just wanted to point out that it's there. So let's go back to the external networks and build out an external network for the lab. So all you got to do is hit this little plus button right here for Add Network, and then select the vCenter server. And I've built a port group out called External Access on the vSphere environment. It's currently set to VLAN 0, which means no VLAN, because it's going to an untagged environment in my corporate LAN, which is basically my home lab LAN. You can change the VLAN in your lab to match whatever VLAN you're using, or you can do like I did and just use 0 if you don't have a VLAN set up. By default, it says these provider VDCs will connect to this new external network. The list there is gold because that's the only one that we've built so far. So there's no even choice for that. It just goes to the provider VDCs and you don't even get to say yay or nay on that. But it needs an external access anyways, so it's going to use this one because it's going to be the only one that we have right now. Click Next. Then we'll configure the external network. So right now there is no external network, and we need to give some IPs that can be used by objects and networks that need to use the external network. So we'll click Add, and I'll put in my information for my corporate LAN. You want to do the same for yours. So mine's 10.0.0.200. It's a class C, which is 3255.0. Put in my DNS server and my DNS suffix. There we go. And then static IP pool. So I'm going to give the external network 10 IPs that it can use if it needs them. And vCloud Director will actually pull out those IPs and use them as needed. As something needs to acquire an IP from the pool, it can grab them. You want to make sure that nothing else can or will use these IPs other than vCloud. So for me, I have a DHCP range in the corporate LAN, which is the home lab, where there's an excluded piece of that range. So for me, it's 10.0.0.150. I'm going to give it from 150 through 10.0.0.159. So basically, it's 10 IPs that it can use to hand out to anything that needs it. It tells you at the bottom, too, that I've got 10 IPs available. So, and the format that I use, just IP start -IP end. Very simple. Click OK. Make sure to hit Add after you put the IP in there. Otherwise, when you click OK, you've basically done nothing. So here we go. We have a pool set up. Currently not used at all because nothing's grabbed one of these IPs. This is good enough for now. We don't need to build any other pools. 10 IPs should be plenty for what we're doing. If you find out later you need more, feel free to modify this and expand it or contract it if that's what you need as well. We'll click Next. We'll give it a name. So this network name is going to be what the object is referred to within vCloud. The external access is the port group name, but it's not going to be called that for the network name we put here. So we can call this the corporate LAN. And I'll say that it connects to the official business corporate LAN, not a home lab. That way no one will know this is a home lab. And next. And here's your typical, is this what you meant to do? Review it, and then click Finish screen, in which we'll click Finish. And there we go. We have our corporate LAN that's connected to the external access vSphere port group. Now, all these names are arbitrary. You can call this whatever you want. Corporate LAN's pretty common, or LAN, because that's typically what you're connected to when you build one of these for your environment. And external access is it's neither here nor there. That's what I typically call it. You could call it the name of the subnet. You could call it your LAN. You can call it whatever you want. It really doesn't matter as long as it makes sense to you. So there we go. You've already built your external network. I mean, pat yourself on the back. That's one thing you can check off the list that you don't have to do anymore. The next thing we're going to go through is build out the 3 types of network pools that aren't VXLAN. So it's basically the port group backed networks, as well as the VCDNI network and the VLAN network. So we'll start with the port group backed. I'll click add. And here's your choices. It tells you VLAN, VCDNI. VCDNI shows up as network isolation backed here. It doesn't say VCDNI. You just have to know that network isolation backed is the vCloud Director network isolation backed, or VCDNI right there. And here's the port group backed. I kind of think that port group backed was put on the bottom because it's the one they don't want you to use, but I don't know that for sure. Also notice that it says a VXLAN network pool was automatically created. So there's not even a choice to make one because they already made one, and it can hold, like I said, thousands of networks, so there's no need to make a second one. So we'll choose port group backed here, and then next, choose the vCenter server. This one's going to be really plain Jane because there's not much to do. I've already made a port group within the vSphere environment called vCloud VLAN 30, and amazingly enough, it's also using VLAN 30. Imagine that. I'm going to add that port group to the list here. Basically, just select it, hit add. And again, it's telling you that gold will have access to this. That's fine. We'll click next. We'll give it a name. So I'm just going to call it VLAN 30 port group backed, just to make the naming easier for you. Port group backed. There we go. Next, and then finish. All right, we have our port group backed VLAN. It's currently right here. It's not used at all. None of these are going to be used right now because we haven't done anything with them yet. And also notice that the VDS shows up as just a dash because the VDS is largely irrelevant because we're using a very specific port group on a switch. It's not necessarily a distributed switch. It could be a standard switch, so they don't even put a name in here. It's just that port group. We'll go on now to the next one. Click add. And we'll do a VLAN backed network. So it looks a little different. You notice it changes itself depending on what you're building. For this one, we'll do a VLAN range. And earlier I talked about 500 to 599. So that works, 500-599. Click add. A little star will remind you too. And then we'll click Chicago vCenter, the vCloud distributed switch, and that's it. From there, it'll do the rest. Now, I will caution you, if you're going to build out a VLAN-backed pool, like I show you here, and you want to actually play with it in your lab, these VLANs need to be legitimate. And by that I mean your physical switch needs to already be configured to pass traffic on these VLANs. Because vCloud Director can't go in and change the configuration on your physical switch. It doesn't have that kind of power. So these VLANs need to already be configured and basically allowed on your physical switches, or else it won't work and you'll probably scratch your head like, man, this is not working. What did I do wrong? That's pretty much what people do wrong, is they forget to actually make the VLANs. So click next, give it a name, call it VLAN backed. Doesn't matter what you call it. And I'll say, actually I'm going to say 500 to 599 VLAN backed. VLAN backed, and then next, and finish. All right, notice with this one, it does say type is VLAN and shows you the distributed switch because it's important. It's going to build port groups on the vCloud distributed switch. So that's why it has it recorded there. Let's do the last, the VCDNI network pool, which is right here, network isolation backed. Click next. Now, got number of VCD isolated networks. I'll show you something real quick. You can put in a lot of numbers and it goes red if you get too big. So when you get to 1,000, basically, it's saying no more. I won't do it. 1,001 won't do it. 1,000 works. So if you need 1,000 networks, I don't know if you do or not. Just saying. I won't judge. You can do that. We're just gonna do 10 because I don't want a giant number. So the VLAN ID is basically saying what VLAN should I use under the covers on my VCDNI network. And I'm just going to use, I've got a VLAN configured VLAN 20. I'll use 20, and that's fine. Notice that there's 4096 VLANs, but I can't use that VLAN number. I can't use 5 either. I can use 4094, but 4095 and 4096 are reserved numbers, so don't try to use them. There's a couple other ones that potentially don't want to use, but those are the ones I see people hit thinking, oh, I'll just use the largest one, and it doesn't work out. So I'm going to use 20. And the same kind of process here. Choose your vCenter server, choose your distributed switch, click Next, and then we're going to do a name for it. So I can call it VLAN 20 VCDNI and VCDNI. Call it whatever you want. Next, and then finish. The names are just there to make your life easier. It has no impact on the actual program itself. Okay, so now we've built 3 different network pools. I can't claim credit for the VXLAN network pool because vCloud Director did that for me. But so you and I created 3 network pools, and we also made an external network. At this point, everything else is going to be tied into actually building out some organizations, building out some organization VDCs, and throwing some vApps in here so we can network with them. So we'll cover that in a future lesson, but now you've got all the underlying networking pools created so that you can do those activities as we move forward with the course. So I hope you enjoyed this lesson, and I look forward to seeing you in the next lesson.